Directional couplers, how its name is couplers and how it's going to provide the directivity. And here we'll see that about two-hole directional couplers which have four ports, and we are going to see their S matrix also, and we'll see the expression for the coupling coefficient as well as directivity. So still, if you didn't subscribe our channel, please subscribe it and share with your friends. So this is very important question. They used to ask multiple time, describe, explain about this directional coupler and derive the S matrix. That is the S scattering matrix. Before this, we have discussion about all hybrid parameters as well as we have S matrix for the E plane, S plane, magic T and red race rings or circuits in the previous lecture. So directional coupler here, whatever we are going to consider, so it has two waveguides. One is the primary waveguides, another is the secondary waveguides. So primary waveguide is connected to the port 1 and 2, whereas the secondary waveguide is connected to the port 3 and 4. So we are expecting that all ports are terminated with characteristics impedance so that reflection will not occur between port N1, 2, we have proper transmission when there is no reflection. And there will be no transmission between port 1 and port 3, odd number of the port, and port 2 and 4, that is the even number of port. So here if you see in the diagram, in the primary waveguide, we have port 1 and this is the port 2. In the secondary waveguide, we have port 3 and port 4. So when we are connecting the source to the port 1, then what you are seeing that here possibility that it can be transmitted to the port 2 as well as port 4, but it will not be transmitted to the port 3. Okay, so this is the coupling between the primary waveguide to the secondary waveguide. Only it can go through the port 4, not through the port 3. Similarly, if you apply that reverse of this, okay, then again there will be no transmission between the port 2 and port 4. So first of all, we are saying what is the coupling factors. Okay, so it is going to measure the ratio of power levels in the primary as well as secondary lines. So P1 is connected with source and how much power is being transmitted to the P4. So that is going to give us the ratio of that is going to give us the coupling factors. So in the dB, we are writing 10 log 10 P1 by P4, where P1 is the power at port 1, P4 is the power at the port 4. Similarly, we are talking about the directivity. Like in case of antenna, we are talking about the directivity. Where you want to send, there it should reach. Okay. So here, this directivity is going to say that how this primary waveguide is couples only to the specific port of the secondary waveguide where you want to send the information, where you want to send the signals. So directivity again, ratio of power at port 4 and power at the port 3. So in the dB it is given as 10 log P4 by P3. So we know that this transmission should not take place between port 1 and port 3, between port 2 and port 4. So this directivity. So now if you see that in case of ideal directional couplers, it has infinity directivity. But in practical, we are going to achieve only 30 to 35 decibels. That is the directivity. So directivity means it is very high, means where you want to transmit from port 1, like you want to transmit to port 2, it should reach to the port 2 only. Want to transmit to from port 1 to port 4, it should reach to the port 4 only. That is the meaning. So there are several types of the directional couplers. One is the two-hole directional couplers, another is the four-hole directional couplers, another is the Esquinger coupler, and next is the with a hole directional couplers. So as per questions or what they are asking regularly, we have two-hole directional couplers, but you can see that how two-hole directional coupler is going to look and how four-hole directional coupler is going to look. So in case of two hole, here you see that two holes are separated by the distance lambda z by 4. Whereas in case of four hole, one hole is here, second hole, third hole, fourth hole. So the separation you can see here. Between 1 and 2, we have A. Between 2 and 3, we have B. And between 3 and 4, we have A. So later we'll have discussion about all this dimension of the 4 holes. Here we are going to see only about 2-hole directional couplers. What we are going to see? Only 2-hole directional couplers. So that that spacing between the centers of 2 holes. Like here earlier we have written about like if n equal to 0, then it is lambda g by 4. But if you are going to write in general, what can be the separation between 2 holes? That is L equal to 2n plus 1 into lambda g by 4, where n is what? Any positive integers. Okay. Any positive integer is the n value here. And this is the general expression. So primary waveguide, secondary waveguides, and the separation between these 2 holes, hole 1 and hole 2, we have 2n plus 1 into lambda g by 4. And already you know that there will be no transmission from the port 1 to port 3 as well as from port 2 to port 4. So now source is connected where? At the port 1. So now here if you see that you can consider 2 different colors to write in the exam. So one is the transmission takes place from the port 1. It is going to the port 2. Okay. And from the hole 1, again it is being going through this and going to pass. It is a possibility that it will go towards the where port 3 and port 4. So this is when it is going to only going through this hole 1. Again at hole 2, what is happening? It is going to split towards the port 3 as well as port 4. So at port 4, what we are saying that both are being added together, whether it is coming from the first hole or it is coming from the second hole, both are being added at the port 4. Whereas at port 3, it is being cancelled. Whatever signal we are going to obtain from the hole 1 as well as hole 2, both are being cancelled here at the port 3. So there is no transmission between the port 1 and port 3. Okay, we can transmit from port 1 to port 2 as well as port 4. So that now a fraction of the wave energy, what we are saying that it is being entered to port 1 and is going to pass through the holes, and finally you have seeing that how it is being radiated in the secondary waveguides. All this discussion we have here. So here we have again forward wave in the secondary guide, okay, that are in the phase. So when it is going to emerge at the port 4, so both are in the same phase. But at the port 3, it is going to be opposite in the phase. Due to that, it is being cancelled out. So that backward waves in the secondary guides are out of phase by 2L by lambda z into 2 pi. Radian. Okay, these are the radian. So it is being cancelled at port 3 and it is being added at the port 4. Now we'll try to derive what is the S metric or scattering matrix of the directional couplers. If they're asking only about explain about the directional couplers, so that part is enough. But if they're asking more about S matrix, derive the expression of the S matrix as well, then we have to continue this portion also. So since it is 4 ports, so it will have 4 cross 4 matrix. Okay. And already we have seen that these ports are matched properly. So we have S11, S22, S33, S44 equal to 0. And there is no coupling from the port 1 to port 3. So that this elements of the matrix S13 and S31 is going to be equal to 0. Same way, we don't have coupling from the port 2 to port 4. So S24, S42 is going to be equal to 0. So on the basis of that, we have reduced S matrix where whatever elements are 0 that we are putting as the 0. Next, we are going to use the zero property of the S matrix. What is the zero property of the S matrix? The element of one column is being multiplied to the conjugate of the another column. So here if you see that column 1 is being multiplied, okay, or you can take in the row wise also. Both thing is possible, that both we can take here. Okay, so now here we have like we have taken as the row wise S12 multiplied with the S14. Okay, so this is the row, this is the column. So second column, fourth column. Again, this element of this better we can take column. So 4 column, second column and fourth column. So both are multiplied with their conjugates. Elements. So what we are doing, zero property. Elements of the one column is being multiplied with the conjugate of the element of the another columns. So that sum is going to become equal to 0. So that is happening column 2, column 4, column 1, column 3. In case of unity properties, the element of the particular column is being multiplied with the conjugate itself. And then finally their sum is going to be equal to 0. That is going to be, sorry, 1. So that is called as the unity property. When sum is 0, that is the 0 property. When sum is equal to 1, that is the unity property. So finally, if you see that this equation 5 and 6 can be written as modulus of S12 into S14. Again, we have modulus of S32 and modulus of S34. So equation 8 is here. Again, modulus of S21, modulus of S23. And again, modulus of S41 and modulus of S43. We have equation 9. And by symmetry, you see that S12 is going to become S21, S14 is going to become S41. And S23 is S32, S34 equal to S43 by the symmetry of the matrix. So now if you substitute the value of this in the equation 8 and 9, and if you compare, then we can have modulus of S12 equal to modulus of S34. Why we are using modulus means the modulus of the conjugates, okay, also is going to give the positive values. So on the basis of, we are getting equation 10 as well as equation 11 by using the 8, 9 and these symmetry properties. Now, if you are writing S12 equal to S34 equal to P, so where P is some positive as well as real, then equation 6, okay? So that we can write as P into S23 conjugate plus S41 equal to 0. Again, if we are considering here S23 equal to S41 equal to JQ, that is equation 14, and Q is the positive and real. Okay, P was also positive and real, and Q is also positive and real. Then this equation 7 will become P square plus Q square equal to 1. So this is the final S matrix of the directional couplers where these values are being replaced. What are the value? S12, S34 is replaced by P, and S23, S4, 1 is being replaced by JQ. So this is the equation 16 is the final S matrix of the directional couplers. So this is very important questions. Okay, please like, share and subscribe. Share with your friends. Any requirement is there, any comments, all things are welcome. Thank you. Thank you very much.